Hi, I'm Tal, co-founder of Arato, and we're going to talk about testing conversational AI. Again, some of the things here are conceptual, so happy to talk about them offline. Oh, sorry about this. I get some. All right, so we're going to start talking about testing a single prompt just to kind of level set. Then we're going to talk about multi-step interactions like chat. And finally, we're going to talk a little bit about testing agents. So for testing a single prompt, we'll cover the basic building blocks. I'm assuming that people here on the talk already have some grasp of how this is done, but I'll just do this to align. And if not, I refer you all to the YouTube channel of Prompt Practices. There are a lot of talks there on these topics. So the first building block is a prompt template, right? So normally when you write a prompt in ChatGPT, you just write the whole prompt. But when you implement LLMs in your application, you would normally have a template, right? Like with placeholders that would take dynamic data. It can be user input, it can be your application input, but this is what makes the prompt actually useful for an application use case. And we call these variables, right? So here, a simple example of translating something from one language to another, and we have these variables here. The next building block is a dataset. So actually, and I'll show some examples of ready-made datasets, but I think that's a lot of where a lot of the effort goes into curating your datasets. In this case, the dataset includes the concrete values that would go into the prompt, the template, and very important to have some kind of labeled data or expected output or ideal output. This is basically what we expect of the LLM, right? And we will use it later in our test. In this case, it's just a word that we expect the LLM to respond with when we ask it to translate something. So if we put this together, I have the data set here, and these concrete values will be replaced in the prompt template, produce the real prompt that will go to the LLM, and then produce the output. Then come Evals. So Evals, as Alden also mentioned, is where the test logic lies, right? This is where we have a chance to validate that the LLM is responding as we expect. We can have multiple evaluations. Some of them are about the output itself. In this case, I would probably want to make sure that the values match. If it's a longer text, then exact match is no longer useful, and there are other metrics like semantic similarity and some other metrics to evaluate if the output is as we expect. And of course, there are other evaluations we can run here to test everything else about safety or any other aspects that we want our like the behavior of the LLM. And so this is just one interaction. A test would normally need to run through a lot of examples on like basically iterating over the data set we have here, run the evals for each of these prompts, and then produce some aggregation of the response of the evals. So if we're putting this all together, I have the prompt here for a translator bot with the placeholder or the variables, and then I have the data set with the concrete values and the expected or ideal output. And then I will define a couple of evaluations. In this case, I'm defining one evaluation that verifies the correctness of the translation, and the other one is just looking at the length of the text. In this case, I'm expecting one word, and then we have the evals results for each line, as well as some aggregation. So this is the basic building blocks of a single prompt test. Okay, this was all just to level set. So going into multi-step interactions, chat, for example, we start to see something a little bit different, because in this case, we're not only testing a single prompt, but we're also testing a whole interaction. So our data set will now need to include this thread and a bunch of prompts and responses corresponding to the thread. Okay. In this chat example, like in this coding assistant example, this is just trying to help me solve some coding problem, and I have some examples here of what I expect my chatbots to reply with. Now the challenge here is that there is this concept of a context accumulation, right? In the case of a single prompt, it's kind of it has the LLM knowledge, but it will only reply to my current prompt. When I look at the thread of interactions, each interaction adds to the context of the conversation. We won't go into the details of how this is done. There are multiple ways to kind of build up that context, but it does create a new challenge, which is how do we test the convergence, right? So if we look at the run example, we can see here I have some similarity metric that tries to compare the my expected output to the actual output based on the user input, and we can see that there is some divergence. So as we go deeper into the thread or the conversation, the data set starts to diverge from the actual outputs that I'm getting from the LLM. Again, because the user input is dynamic, right? So I can't really get exact matches every time. And this normally means that I need to start improving my prompt, right, to try to get that divergence to be as minimal as possible. So in this case, I would be writing another eval, okay, that would tell me like how fast is this diverging. So this eval will not be looking at just one line, but it will be looking at this whole thread. And my goal as a prompt engineer would be to try to reduce the divergence of threads. So if we kind of try to summarize what is the strategy for testing a multi-step interaction? So in addition to testing an individual prompt, we would also need to build an evaluation that would look at the entire thread and try to identify divergence. So again, we will be using the same building blocks, the same data sets, but we'll structure them a little bit different, and the same mechanisms of evaluations to detect divergence. We'll quickly talk about testing agents. So this is kind of more conceptual, because I think like many people are talking about agents, but we're just getting started. So before we start, let's talk about how an agentic framework architecture looks like in a high level. There are a few available frameworks like this, but I think they're all kind of show a similar architecture. So there is a bunch of agents. Each agent is normally quite isolated in the kind of things it can do, right? So I have, in this example, a web search agent and a file search agent and a flight booking agent, and maybe many more that are available for my application. These normally share some kind of shared memory or knowledge management. And there is a component here which we'll call an agent orchestration layer. And the role of this orchestration layer is to take the user request and to build something that is usually called an execution plan. So the execution plan is the attempt of the framework to say, okay, I'm taking the user's inputs, I'm understanding what kind of agents I have available, and I'm going to create tasks and assign them to this agent, and then run these tasks as best as I can. And it's important to note that this execution plan can be built in code, which is actually then it's not dynamic. The graph will be very, very static. But it can be built with an LLM, meaning that the execution plan can vary based on what the LLM understands. And it can be also built dynamically. So based on what the agent replied and what is added to the shared memory, the orchestration layer will choose kind of the right next step. So if before we had a problem of testing convergence, now we have a problem of testing convergence, right? Because it's a much more kind of unpredictable path that our agents will take. But if we try to kind of, again, have use the tools that we already know, we can really do or break up the system in a way that we will test each agent independently as if it was a multi-step interaction, as we saw before, because each agent has a very specific task. And we can look at the agent orchestrator as yet another agent, right? Like its role is to create this kind of graph, and we can see how it behaves and how it diverges or converges to the same expectation that we have of what kind of execution graph it should be built. So we can really kind of look at this in this way, is that we have the building blocks, what we saw about for testing, sorry, a single prompt. When we look at multi-step interaction, we still use the same capabilities, but we now need to create evals that look at convergence. We do need to build maybe a different data set, but it's still within the same building blocks that we have. And when we extend to testing agents, I think again we'll be able to use the same tools that we already know to also extend to testing agents. I think like the main takeaway that you should have from this is that, and this is kind of a rule in testing in general, not just for LLMs. The value to effort of testing a unit or a smaller piece is normally much, much higher than the value to effort of testing the integration of an entire system. And therefore, a lot of the effort to go into really testing the individual units, the individual prompts, then you should extend to testing maybe a few use cases for your agent or for your chat that are looking at kind of an entire thread. And agents, I think maybe you will have much less tests, but they will kind of just capture the main flows of the application. Yeah, that's that. Thank you.